All seems to be going smoothly when disaster strikes at 125 miles an hour. LaVey's Mercedes collides and blows up.
I managed to get the chassis out of the case that appears to be a casting. And one of the more difficult things was removing the dial, which is a very fragile plastic piece. So this video gets me halfway into the radio. I'm going to begin to remove and replace parts, and probably one more video to finish up the series, but I'm not going to get through it all in this one, but some progress is being made. You'll notice that the parts are exposed on the bottom of the chassis, so you got to get the thing out. Boy, am I ever glad I didn't try to fire it up from scratch, because there were a lot of problems with this radio when uncovered. So let's talk about the restoration of this thing. Got this big crack down through the middle, got some damage on the corner, and these go pretty much straight through the plastic, so I don't think I'm going to take the approach of using some type of auto bondo stuff, something like that. I'm going to use some epoxy, something that will give some strength as well as penetrate into the cracks a little bit. So I've got some JB Weld epoxy here. It's just something that claims it works on most plastics. We shall see. And then I'll sand that down, put some type of a protection over the logo, and attempt to give it some kind of a finish. It's not going to match the color perfectly, but this is some hobby craft paint that should do okay. And also some Testors flat black enamel, and that's about as far as I'm going to go. Let's see if I can accomplish that without breaking something. Over the years, I've been able to collect quite a few battery tubes, and I found a few examples of some American substitutes. These tubes are equivalent to X17, W17, ZD17, and N17. It's good to have on hand because when you're working with the radio and you happen to have a tube tester of some kind, you would like to check similar tubes. So it also brings back the idea that is the tube tester the definitive source? And most people know now that tube testers are at best a quick check for something catastrophic like an open filament or perhaps a tube that's completely bad. I've found that tubes that read regularly as replace, like here's a 1R5, and you can see it's clearly in the replace. That's a perfectly fine tube. If I put 5 1R5s in there, they would all read just like that. So this is the converter section. Let's put another one in. These are known good tubes. Let that warm up for a second. These are pretty quick heating, almost identical. So this is a problem with the tube tester, not the tube. So just keep that in mind. The definitive way to test a tube is to always test it in the circuit. Yeah, I have V1, the X17 plugged in. That may or may not be fair, but figuring they're both converter tubes and one's based on the other. And it's in the same range, a little bit lower than the 1R5s were, but this is the converter section. I also have to test the oscillator section of the tube, which is a different section, so you have to set the tube tester up separately for the oscillator section of the heptameter. So the oscillator section of the tube is reading good on the X17. So I think we have a tube that's just fine. So here's the IF stage, the W17, and it's reading good. Interestingly enough, when I set it up for the 1T4 American tube, I got a little surprise. This should be the equivalent, and it's dead. It turns out that the tube has an open filament. So this is what you use the tube tester for, to test for bad tubes, and this guy is bad. I got a surprise on the detector tube. It's not a Marconi. It's a Mullard DAF 91. So this tube has already been changed by somebody in history. So let's see if we can test the diode section. And of course it says replace, but then it says below diode's okay. So the diode is okay in the tube. Something interesting about the detector tube, the ZD17-1S5, and in our case it's been replaced with the DAF 91. It's made by Mullard, and you notice the top of the tube, it's 4 parts. They seal the top, and it's got a mechanism that makes the nipple on top, and there are 4 marks in the glass. Notice that this CBS Hytron tube also has those same marks. So I'm thinking that Mullard must have made the tubes for CBS in the 60s. And finally, the output tube, the 3S4 N17 or DL92. This is a good tube. The N17 comes right up. I do have a 3S4 I want to try. This is supposed to be an equivalent. So let's see what we got here for the 3S4. If I can get it in the socket. Warm up a little bit. Okay, actually the N17 has more gain than this American 3S4. So we've got some replacements. Now the N17 audio output, which is the equivalent to the 3S4, that was a tube that was replaced by a lot of different power tubes over the years, some with more emissions, and there's a lot of compatible tubes that really aren't listed and will perform in the socket. And you might run into some of these tubes like the 3 Alpha 4, the 3 A4, the 3 Q4, and you're probably familiar with the 3V4, which is a modern equivalent. But the 3V4 has a lot more gain, so it might actually cause some trouble using a 3V4. But there are other substitutes worth trying in that N17 socket. Of course, there's a big temptation just to hook up power to this thing and see if it works, but I try to be methodical, especially with a radio that I'm unfamiliar with. This doesn't look too bad inside, but I can see that some soldering has been done in here. Some soldering has been done in the unit. It's definitely had some work done over the years. So I'm going to remove the chassis, or attempt to remove the chassis, just so I can figure out how you do it. And probably would like to do that anyway, because when I do the plastic work with the filler or the glue and do the painting, I think I want to do that with the plastic off the chassis and off the support, so as not to damage things even more than it is. Okay, here's where I ruin the set. Basically dismantling, open the lid, very carefully ease off the tuning knob, which is push fit, and place the receiver face downward again. Well, getting this off without breaking it is going to be very interesting. Okay, does anybody honestly believe I'm going to get this knob off without breaking it or scratching something? We have to remember that these radios were considered throwaway. That is, after a few years of use, they go into the dust bin. But I will try to take the knob off. By the way, somebody might have already done this, busted the knob and glued it on or something like that. So it's just going to guarantee that the knob is going to be broken. Now, I'm using 2 slot adapters in various ways to try to gain leverage towards the middle of the spindle to try to get this thing to release off the shaft. We'll see how successful I am. The slot adapter idea seems to have popped it up, and my God, I've gotten the knob off. Look at this. It's intact. Success. Probably the first person in history to get this thing off. Or I was just very lucky. I hope you weren't betting on me. I don't actually understand why, but this plate was already loose, and it reveals the loop antenna inside. I'm going to unsolder these two because I don't want that to get in the way of removing the chassis. Okay, I've now unsoldered the loop antenna, and I'm ready to pop it on its head, and we'll try to drop the chassis out. Okay, next the instructions say to remove each of the 6BA nuts in the corner of the assembly, and I have a nice nut driver to be very helpful to take these nuts out. Now they appear to be 3/16 OD 440s. Okay. Oh, look at that. Look at that. And this chassis is cast. Yeah, I think it is. Maybe not. Maybe it's steel. Yeah. Cast steel. Wow. Okay. Well, again, we're counting our successes one at a time. It's not over yet. The chassis is connected to the front panel with yet another set of nuts. So we have to take these off. Now these nuts are thinner, and you can see all kinds of signs that this has been done once or twice before. So somebody has done some work on this chassis. Just continue to take the nuts off till we get all 4 off. So these 2 need to come off too, because this doesn't want to release without those guys. Okay, actually it just needed this one in the center removed. Didn't need both of them. So this one is part of the chassis, so you don't need to take that other one that appears to be near the speaker off. Okay, it is released, and I can see the bottom side of the chassis. Now, some of you have heard of the concept of shotgunning. That means replacing capacitors that look like they're old en masse. And I'm going to look at the schematic carefully and see what needs to be replaced here. My guess is that the ceramic capacitors are okay, but a lot of these paper type caps, they just need to come out and get replaced before I do anything more. I've taped some cardboard over the speaker so that while I'm doing some soldering here and repair, we're not going to damage the speaker accidentally. So these were the 2 wires that feed the antenna. These are the 2 wires that need to be unsoldered to disconnect the loop antenna. So these 2 get unsoldered. The set is now dismantled. The nuts and delicate parts are put in a baggie, and I can get down to that part that everybody enjoys, replacing electrolytics and paper capacitors. So I can see a couple of electrolytics that are going to need to be replaced, and on this side there's several paper capacitors I can see. Next step is to start to work on some of that stuff. Check the resistor values, see that they haven't gone up too much. want to talk a little bit about the replacement components that we're going to be using for this antique receiver. As you can see, the resistors are old-fashioned carbon composition. Some of them are kind of bulbed up a little bit from having so much water that's gone inside them. I am starting to replace components. See, this is a little more modern carbon composition resistor that I'm replacing one of these older style with. All of the resistors were far out of tolerance, almost 100% of their value they've gone up. So I'm going to replace all of them. At first I didn't think I needed to do that, but after measuring them, these things have drifted pretty badly. The paper capacitors I'm beginning to change out, and I'm putting in these mylar caps here. When you're picking capacitors, it sure would be nice to find some axial lead mylar capacitors like this or like this, but sometimes you are forced to use the radial lead caps and form the leads, as you can see I've done in here. Any of these types of caps would be fine, and they probably fit okay. On the two electrolytics, you're looking for something like this. You need to have a voltage range that's at least as much as the 67 volts of the battery. It's probably good practice to double that, so 150 volts on these caps is a minimum. This happens to be a 630 volt capacitor, but it's not too big and it did fit in. You can stick with the carbon comp resistors, but I'm going to warn you that most of them that you're going to find are vintage, and they've gone up in value so much they're probably not going to be usable. So the carbon film is a better choice. This is a carbon film resistor. Also, there's not a lot of current in this radio, so using a 1/4 watt type resistor instead of a 1/2 watt I think would be acceptable. So I just wanted to go over a few of the component choices when you're recapping and putting new resistors into this radio. So rather than shotgunning all of the capacitors out, it's a good idea to look at the ones that are most suspect. And the ones that are most likely to be bad in this radio are the two electrolytics. There's a 2-mic. They call it the high tension reservoir. That's neat. And a GB bypass. So I imagine that's grid bias. Okay. So it's a 20 mic and a 2 mic electrolytic. Those need to be replaced. There's a couple of 0.1s. One of them is the very important automatic gain control. Okay, up here, the automatic gain control. There's also a screen grid decoupling cap. Those are both 0.1s and they're both suspect. Here's another 0.1. It's another screen grid bypass. And it looks like there's a couple 005s. The tone corrector. He's possibly one we want to look at. And audio coupling, C14. And then the rest of them look to be mica capacitors. It's funny, they're doing all the values in microfarads. And instead of picofarads, like 100 picofarads, they're doing 0.0001 microfarads. And I remember some of the old radio and TV guys used to call those 000 caps. So a 000 cap is a low value, usually a mica or a ceramic capacitor. So it looks like we got 1, 2, 3, 4, 5, 6, 7 target capacitors. And while I'm in there, I will check the resistor values and see that if they're all very high values, and high value resistors do tend to go very high in value as they age. It's characteristic of battery type portables to use very high impedances in order to reduce the battery drain. So those are extremely high values compared to the typical All-American 5 or, you know, the typical AC operated table radio. Those are very high values. So I am seeing a little problem here. This is R11 and C19 right here on the schematic. This conglomeration here, it's a 1K resistor and a 20 microfarad. And as you can see, it's switched through S3. Well, the place where it's supposed to be connected is connected down to ground instead. So they have it wired on permanently. So they have wired the high voltage on permanently instead of letting it go through S5, the switch. So I don't know what's going on there, but I'm going to... What this is telling me is this radio has had some work done. I can see on the other side that there's been quite a few components played with and some soldering has been done. And I'm very glad I didn't try to just fire this thing up. Wow, this is bad. This wire is not even soldered. It's just wrapped around with a little knot. This is going to take a little work, but we'll get this thing back together. Some of the soldering on this thing is just the some of the worst I've seen. So removing the chassis from the casting was a little bit of work because you had to remove a plastic knob that came up through the front of the chassis, and getting this off was really interesting. You do not need to remove the band switch. I've already started to do some work on this side. I've replaced some things here, but this video will get us halfway into the restorative part of the process, and one final video will handle the battery and the finishing up and the alignment, and hopefully finish it out on the third video.